Good morning, one and all. This is CH Likita from CSC Data Science B section. Today, I cover the topic of system of equations in this presentation. The introduction topics are system of linear equations, solution of a system, types of systems, system of linear equation by substitution method, system of linear equation by elimination method, and the special cases which I covered in this introduction. System of linear equations. What is a system of linear equation? A system of linear equation consists of two or more linear equations. This section focuses on only two equations at a time. The solution of a system of linear equations in two variables is any ordered pair that solves both of the linear equation. Solution of a system. Here is an example of a linear equation. The question is determine whether the given point is a solution of the following system. The given point is minus 3 comma 1 and the system of the equations are x minus 3y is equals to minus 4 and 2x plus 10y is equals to 4. Plug the values into the equation. The first equation is minus 3 minus 1 is equals to minus 4. Hence the first equation is the true equation and the second equation is 2 into minus 3 plus 10 into 1 is equals to 2 3s are minus 6 plus 10 ones are 10 minus 6 plus 10 is equals to 4. Hence the second is equation is also a true equation. Since the point minus 3 comma 1 produces a true statement in both the equations, hence it is a solution of a system. And here there is another example. The question is determine whether the given point is a solution of a following system. The point is 4 comma 2 and the system of the equations are 2x minus 5y is equals to minus 2 and 3x plus 4y is equals to 4. Plug the values into the equation. The first equation is 2 into 4 minus 5 into 2 is equals to 2 4s are 8 minus 5 2s are 10 is equals to 8 minus 10 is equals to minus 2. Hence it is the first equation is a true equation and second equation is 3 into 4 plus 4 into 2 is equals to 3 4s are 12 plus 4 2s are 8 is equals to 20. Hence the second equation is the false equation. Therefore, since the point 4 comma 2 produces a true statement in only one equation, so it is not a solution. The next topic is finding solution by graphing method. Since our chances of guessing the right coordinates to try for a solution are not that high, we will be more successful if we try a different technique. Since a solution of a system of equations is a solution common to both equations, it would also be a point common to the graph of both equations. So, to find the solution of a system of two linear equations, graph the equation and see where lines intersect. Since graphing is a different technique of finding the solutions. So here there is an example. The question is solve the following system of equations by graphing. The first equation is 2x minus y is equals to 6 and x plus 3y is equals to 10. The first equation in the graph is 2x minus y is equals to 6 and second equation of a graph is x plus 3y is equals to 10. The line appear to intersect at 4 comma 2, so we can see the graph it intersect at the 4 comma 2. Although the solution to the system of equation appears to be 4 comma 2, you still need to check the answer by substituting x is equals to 4 and y is equals to 2 in into the two equations. The first equation is 2 into 4 minus 2 is equals to 2 4s are 8 minus 2. 8 minus 2 is equals to 6. Hence it is the true equation. And the second equation is 4 plus 3 into 2 is equals to 4 plus 3 2s are 6. 4 plus 6 is equals to 10. Hence the second is equation is also a true equation. The point 4 comma 2 checks, so it is a solution of a system. So here there is another example. So the question is, solve the following system of equations by graphing. Minus x plus 3y is equals to 6 and 3x minus 9y is equals to 9. First, the first equation of a graph is minus x plus 3y is equals to 6, and second equation of a graph is 3x minus 9y is equals to 9. The lines appear to be parallel, so we can see in this equation there is no any intersecting lines. The lines are a parallel. Although the lines appear to be parallel, you still need to check that they have the same slope. You can do this by solving for y. The first equation is minus x plus 3y is equals to 6. Now add x to the both sides. We will get 3y is equals to x plus 6. Now divide both sides by 3. We will get y is equals to x plus 2. Second equation, 3x minus 9y is equals to 9. Subtract 3x from both sides. We will get minus 9y is equals to minus 3x plus 9. Divide both sides by minus 9. We will get y is equals to minus x plus minus x minus 1. Both lines have a slope of minus, so they are parallel and do not intersect. Hence there is no solution out to the system. The another example is solve the following system by equations by graphing. X is equals to 3y minus 1 and 2x minus 6y is equals to minus 2. The first graph of a equation is x is equals to 3y minus 1, and second equation of a graph is 2x minus 6y is equals to minus 2. The lines appear to be identical. We can see in the graph the line is an identical line. Although the line appear to be identical, you still need to check that they are identical equations. You can do this by solving for y. First equation, x is equals to 3y minus 1. Add 1 to both sides. 3y is equals to x plus 1. Now divide both sides by 3. We will get y is equals to 1, and second equation is 2x minus 6y is equals to minus 2. Now subtract 2x from both sides. We will get minus 6y is equals to minus 2x minus 2. Now divide both sides by minus 6. We will get y is equals to minus 1. 1. The two equations are identical, so the graph must be identical. There are an infinite number of solutions to the system, all the points on the line. The next topic is types of systems. There are three possible outcomes when graphing two linear equations in a plane. The first point is one point of intersection, there is a no solution, and second point is parallel lines means there is a no solution, and third point is coincidence lines means infinite number of solutions. If there is at least one solution, the system considered to be as consistent. The system defines distinct lines. The equations are independent. Change both linear equations into slope intercept form. We can then easily determine if the lines intersect, are parallel, or the same line. Here is there is an example. The question is, how many solutions does the following system have? The first equation is 3x plus y is equals to 1, and second equation is 3x plus 2y is equals to 6. Write each equation in slope-intercept form. The first equation is 3x plus y is equals to 1. Now subtract 3x from both sides. We will get y is equals to minus 3x plus 1. And the second equation is 3x plus 2y is equals to 6. Now subtract 3x from both sides. We will get 2y is equals to minus 3x plus 6. Now divide both sides by 2. We will get y is equals to minus 3 by 2 plus 3. So since it is in the lines of intersecting lines, since they have different slopes, so there is one solution. The another example is how many solutions does the following system have? 3x plus y is equals to 0 and 2y is equals to minus 6x. Write each equation in slope-intercept form. The first equation is 3x plus y is equals to 0. Subtract 3x from both sides. Y is equals to minus 3x. And second equation is 2y is equals to minus 6x. Divide both sides by 2. Y is equals to minus 3x. The two lines are identical, so there are infinitely many solutions. The another example is the question is how many solutions does the following system have? 2x plus y is equals to 0 and y is equals to minus 2x plus 1. Write each equation in slope intercept form. The first equation is 2x plus y is equals to 0. Subtract 2x from both sides. We will get y is equals to minus 2x. And second equation is y is equals to minus 2x plus 1. It is already in a slope intercept form. The two lines are parallel lines, same slope but different y-intercept, so there are no solutions. The next topic is system of linear equation by substitution method. Another method that can be used to solve system of equations is called substitution method. You solve one equation for one of the variables, then substitute the new form of the equation into other equations for the solved variables. How substitution method can be solved? Here is a 5 steps. The first step is solve one of the equation for a variable. The second step is substitute the expression from step 1 into other equation. The third step is solve the new equation. The fourth step is substitute the value found in step 3 into either equation containing both variables. The fifth step is check the proposed solution in the original equations. Here is an example for substitution method. The question is solve the following system of equations using substitution method. The first equation is y is equals to 2x minus 5 and 8x minus 4y is equals to 20. Since the first equation is already solved for y, substitute the value into the second equation. 8x minus 4y is equals to 20. So 8x minus 4 into y value 2x minus 5 is equals to 20. Replace y with results from the first equation. Use distributive property. 8x minus 4 2s are 8 means 8x minus into minus plus, since 4 5s are 20 is equals to 20. Simplify left side. 8x minus 8x will be cancelled. So we will have 20 is equals to 20. When you get a result like the one on the previous slide, that is absolutely true for any values of the replacements for the variables, that this indicates that the two equations actually represent the same line. There are an infinite number of solutions for this system. Any solution of one equation would automatically be solution of the other equation. This represents a consistent system on the linear equations or dependent equations. Here there is an example. The question is, solve the following system of equations using substitution method. 3x minus y is equals to 4 and 6x minus 2y is equals to 4. Solve the first equation for y. 3x minus y is equals to 4 minus y is equals to 3 minus 3x plus 4. Multiply both sides by minus 1. Y is equals to 3x minus 4. Substitute these values for y in the second equation. 6x minus 2y is equals 2y is equals to 4. 6x minus 2 into the y value is my 3x minus 4 is equals to 4. Use distributive property. 6x minus 2 3 is a 6x plus minus into minus plus 4 2 is a 8. 6x minus 6x plus 8 is equals to 0. 6x minus 6x will be cancelled. We will have 8 is equals to 4. When you will get a result like the one of the previous slide, this is never true for any values of the replacement of for the variables. This indicate that the two equations actually are parallel and never intersect. There is no solution to this system. This represent an inconsistent system even though the linear equations are independent. The next topic is system of linear equations by elimination. Another method that can be used to solve system of equations is called addition arithmetic or elimination method. You multiply both equations by number that will allow you to combine the two equations and eliminate one of the variables. The elimination method can be solved by these 6 steps. The first step is rewrite each equation in standard form, eliminating fractional coefficients. If necessary, multiply one or both equations by number so that the coefficient of a chosen variables are opposites. And third equation is add the equations. And fourth step is find the value of one variable by solving equations from step 3. And fifth step is find the value of the second variable by substituting the value found in step 4 into either original equation. And sixth step is check the proposed solution in the original equation. Here there is an example. Solve the following system of equations using elimination method. First equation is 2 by 3x plus 1 by 4y is equals to minus 3 by 2. 1 by 2x minus 1 by 4y is equals to minus 2. First multiply both sides of the equations by a number that will clear the fractions out of equations. Multiply both sides of each equation by 12. Here is there is a note. You don't have to multiply each equation by the same number, but in case it will be convenient to do so. First equation is 2 by 3x plus 1 by 4y is equals to minus 3 by 2. Now multiply both sides by 12. 12 into 2 by 3x plus 1 by 4y is equals to 12 into minus 3 by 2. Simplify both sides. Similarly, we can do it to the second equation also. Now we will combine the two equations. 8x plus 3y is equals to minus 18 and 6x minus 3y is equals to minus 24. Now divide both sides by 14. We will get the answer x is equals to minus 3. Substitute the values for x into one of the original equations. 8x plus 3y is equals to minus 18. 8 into the x value is minus 3. So here minus 3. 8 into minus 3 plus 3y is equals to minus 18. 8 3 are 24. Minus 24 plus 3y is equals to minus 18. 3y is equals to minus 18 plus 24. Minus 18 plus 24 is equals to 6. So the y value is equals to 2. Our computations have produced the point minus 3 comma 2. The special cases are in a similar fashion to what you found in the last section. Use of elimination method to combine two equations might lead you to results like 5 is equals to 5, which is always true. This thus indicating that there are infinitely many solutions since the two equations represent the same line. Or 0 is equals to 6, which is never true, thus indicating that there are no solutions since the two equations represent parallel lines. Thank you for this opportunity.